Okay, first thing I'd like to do today is go over your 5 potential kinetic energy calculations that I gave you the last class. We'll go through here pretty quickly, but again, just make sure paying attention. Check your answers. If you make any mistake, correct those mistakes, and then you can resubmit your worksheet or turn your worksheet into the sub. Okay, so in the first problem, what we have here is we again are calculating the potential energy. Specifically, we are calculating the kinetic potential energy of a rock that is 55 kilograms that is sitting at the top of a cliff 27 meters high. So very simply, we follow the equation, for kinetic potential energy, and that's simply mass times the force acceleration due to gravity times its height. So in this case, we're simply going to take the 55 kg and we're going to multiply that by g. G is always 9.8 meters per second squared. And again, just square that. And then I'm simply going to multiply that by the height of 27 meters. Okay. So if I work that out here on my calculator very quickly, I am going to take 55 times 9.8 times 27. I will get 14,553. I have kilograms meter squared per second squared. Okay, and if you remember, we talked about this in class. 53, a kilogram meter squared per second squared is something called a joule, and we measure energy in joules. Now again, as we move on through these problems, you are going to have to remember that this kilograms meter per second squared is equal to a joule. So very important here. I'm going to highlight that just so you remember as we go on. These two things are equal to each other. Okay, so let's just move on to the next one. This time we're using a forklift to raise a 250 kilogram crate. So we got 250 kilograms. Again, that acceleration due to gravity always stays the same, 9.8 meters per second squared. And this time we're only going 6 meters. So again, very simply, just run the numbers through your calculator. To do that, and again, 250 times 9.8 times 6 gives you 14,700. Again, you have your kilograms meter squared per second squared. I'm going to go ahead and just put joules there. Okay, we keep moving on. Again, determine potential energy. Again, we just take our mass. We have a 90 kilogram man. Again, the force of gravity is, or acceleration due to gravity is our 9.8 meters per second squared. And this time he is at 200 meters. Okay, as we go through here and I fix this, we do our math. I take my 90 times 9.8. Again, I'm simply going to multiply that by the 200 and I get 176,400. Okay, and again, since I'm doing energy, that is measured in joules. Okay, now when you get down to number 4, you are going to see a change. In this case, it asks what distance is the book lifted off the floor. Well, distance off the floor is height, so in this case, we are finding h. So if you do some simple algebra and you work with the equation, we can find out that the height, or the distance from the floor, is going to be equal to the potential energy divided by the mass times the acceleration due to gravity. In this case, we have a book that once lifted has 996 joules of potential energy. Now in this case, what you're going to have to remember and what you're going to have to do is that a joule is equal to a kilogram meter squared per second squared. So we're going to actually have to use this in this particular problem to get our units to work out right. Okay, so this is an example of where you need to really pay attention to your units at this point. Okay, and then we are simply going to divide that by our mass. Hold on here, get rid of that little dot. So in this case, our mass is 5 kilograms, and our gravity, as always, accelerates at 9.8 meters per second squared. So there we go. I'm just going to move this over a little bit. That didn't quite work the way I wanted to. Sorry. Get that to go down. I forgot to turn my underline off. Again, I apologize. Get my equal sign over here. So now I'm going to have my 196 kilograms meter squared per second squared. Again, make those into exponents so you can see that they are squared. And underline that. And in this case, 5 times 9.8 happens to be 49. So I'm going to, oops, sorry about that, didn't mean to raise that up there. That's going to give me 49 kilograms per meter, meters per second squared. Okay, now, as you can see here, we'll take our 196, we're going to divide that by 49, and I'm going to get 4. Now here's a big part, we got to include our units. We're asking for distance. If I look here, my kilograms cancel out, my seconds per second squared cancel out. I have meters per second and meters, so one of those cancels out. So I'm left with meters. Meter is a unit of distance. So the book is 4 meters off the floor. Okay, an automobile is sitting on a hill with 20 meters, that is 20 meters high. This time we are finding the mass. So again, we just manipulate our equation to find mass. That is potential energy divided by the acceleration due to gravity. Okay, multiplied by the height or distance from level ground. So we look at our potential energy, and we have quite a bit. We have 362,200. Again, we're going to need to convert that joules to kilograms meter squared per second squared. So I do that, set up my exponents here to show you that I have those two squared. In this case, I'm taking my G, that is my 9.8 meters per second squared, and I'm going to multiply that by my H, in this case 20 meters, Then I go over here and work the problem. I still have my 362,200 kilograms meters squared per second squared. Okay. Now what I am going to do after I get this set up here is I'm simply going to multiply my 9.8 times 20. That'll give me 196. In this case, I have meters squared per second squared. Again, I just use my calculator here. I divide out my problem. I do not know why that keeps doing that on me. Let me zoom that back down. I apologize again. So if I take my 362,200 and divide that by 196, I'm going to get 1,847.95. So if I actually round that appropriately, I'm basically going to get 1,848 as my answer. And then if I look at my units, meter squared second squared, meter second squared, they cancel out. I'm left with kilograms. Okay, so that is how you do your 5 potential energy calculations. Again, if we scroll back up here, we had 14,553 joules. Again, remembering a kilogram meter squared per second squared is a joule. Second one, we ended up with 14,700. In the third one, we found 176,400 joules. In the fourth one, we're finding the height. Okay, so that was 4 meters. The book was 4 meters. And finally, the car had a mass of 1,848 grams. In the second video you'll watch, I will be doing the kinetic energy problems.